At Yugabyte. Yugabyte is a distributed SQL database that uses Postgres for the query layer. So anything that is about the SQL processing, the plans is the same in Yugabyte and in Postgres. So I will do the demo on Yugabyte, but everything I show here works on Postgres. With an extension with PG in plan, I will explain the reason, but more how to use it correctly, because some things can be a bit tricky. And of course, if you have any questions, you can interrupt me. The goal is to have something interactive. And if you have questions after, at the conference or elsewhere, you know how to find me on Twitter or LinkedIn, anything. Okay, so let's start first. My goal is not to explain you that you need ints. In Postgres, by default, you don't have ints to force an execution plan like in other databases. My goal is not to convince that you need it, but to be sure that if you want to use it, you use it correctly, because it's not easy from the documentation. But just a slide to explain why you may need ints. I'm convinced that we need ints in Postgres. And for example, in Yugabyte, we install by default the PG in-plant extension. So the reason, let's take an example. Let's compare with Google Map. If I look at Google Map, how to come from the airport to here, of course, it will show me the best path. And the query planner, the optimizer, does the same, finding the best path to your data. But maybe you want more control on that. And you see that Google Map shows you the best path, but also lets you choose maybe another transport, or maybe some hints about I want to avoid this kind of road, or maybe different possibilities, like if you know that a road is blocked at some point and Google Map doesn't know, then you can also choose to go another way. So with ints, you have the same. The query planner finds the best execution plan, but maybe you have a bit more information on your data. Maybe you have a bug to work around. Maybe you need just some more controls. I cannot imagine just taking Google Map, taking the blue path without thinking, oh, maybe there is an alternative in some cases, not all cases, but some cases. It's like the I feel lucky button of Google. Maybe it's always the right answer that you want, maybe not. So for the query planner, for the optimizer, I just want the same, more control on that. Okay, and why in SQL? Because SQL is a declarative language. In a procedural language, you just code how you access to the data structure. In SQL, you just declare the result you want, and you let the query planner, the optimizer, find the best path. So the query planner generates the procedural code, that is the execution plan. You can look at it to understand the performance complexity of your query, but you can also try another one with ints. And when I use ints, most of the time, it's not to fix an execution plan in production. Most of the time is troubleshooting. I need to understand the query planner decision. I think an execution plan is better, but it chooses another one. How can I understand why it chose that? With ints, I can force another plan, the one I think is better, run it, and check if I missed something or the query planner missed something. So most of the time, you just want to understand the query planner choice, and then you have those controls to understand it. And also sometimes, a plan can be bad, performance is bad, and you just need a workaround. The long-term solution is not to add ints in all your queries. The long-term solution is to have the right settings, the right data model, the right indexes, no bug in the Postgres query planner. But if you have a problem in production, you need a quick workaround, and that can be a way. Just you force the execution plan that works, you don't forget about it, you will try to understand and find the sustainable solution, but for the moment, you need that. And yeah, you may know your data better than the query planner. The query planner knows about your data, what is gathered by analyze. It doesn't know the correlation between two tables, for example. Like if you have a table with countries and a table with cities, if you have queries where city equal Bangalore and country equal India, the query planner will underestimate the cardinality of that, because it will estimate for Bangalore, it will estimate for India, and it doesn't know that most of Bangalore are in India. So you may have this information and give hints to use this information by the query planner. So how do you use it? So that's the Postgres community. When you talk about hints, we don't need hints. A lot of people think they don't need it in Postgres, but some people know that they need it and have built an extension, PGConf. So it's I think some people from a Japanese company did that. So you just install it. I will not detail how to install it. It's quite easy, like many extensions, and this is well documented. I will more focus on the tricky things that may not be clear in the documentation. So here I just have an example if you want to start Docker container with Postgres and PGConf added to it. You don't even have to compile it, you can install it, it's in the package, all that. Okay, so now about the syntax. How do you int? Because the funny thing with ints, they are put in comments. And the main reason is that SQL is a standard language that is declarative. So anything that comes to say how to go to a specific access path to your data is not SQL. By definition, SQL is declarative. So if you have something else to tell to the query planner, it goes into a comment, not to be part of the SQL grammar. And a special comment that starts with a plus. This syntax is basically inherited from Oracle syntax. All databases have different ways to put ints. And those are examples. I will show a demo and explain a bit more, but you put many ints, maybe, and then you close your command, and then you have your statement. And it can be easy if you really understand that it's not so easy. You probably need more than a single int. If you have a complex query and you think that you fixed something with one indexing or one leading int, probably you missed something. It works now by chance and maybe not later. So we will see exactly how to be sure to fully int when you want to be sure to fix one execution plan. And first, where do you put this comment? Usually, I put it first just before the query, before the select. Or maybe if I explain, I put the int there. I looked at the code to be sure what can be acceptable where you put the int. You can have only those characters before the int. So you can say explain, parentheses, and then the int, and then select. But as long as you have something else than that, so you cannot put the int at the end of the query, for example, it will just be ignored. And if there is a syntax error within the int, it just stops parsing, so it will ignore anything that is beside. And the ints are comments with plus. You cannot use the minus in it, just /star. If you use prepare statement, and probably you should use prepare statement if you don't want to parse always the queries that you execute, you put the int in the prepare. which makes sense because the int is something for the query planner. And when you prepare a statement, this is where you give the statement to the query planner. At the execution time, the execution plan may already be there, so too late to put an int. So in the prepare, not the execute. And be careful if you have multi-statement commands. So the int is in front and may affect multiple commands. And also be careful in PSQL, when you put a semicolon, those are multiple commands. If you want multiple statements in one command, you have a backslash. No need to remember that, but just if something is wrong, just remember the rules. My goal is that in the slide, if I have any problem, I go to my slide and I understand what I am missing. I tried to cover all the tricky things. And then in the ints, there are references to objects used by the query, like tables and indexes. And the most important to understand is that it's not a reference to the table name, it's a reference to the alias in the query, because you may use the same table with different aliases in the from clause. So there are references by the aliases. And this is case sensitive even without quote, which is a bit strange when compared with parsing the SQL versus the ints, but just know it. The good thing is that when you explain, you see the alias with quotes or not, and then you just take that to use the, usually if you int, you already have explained the plan and you just don't want this plan. So you can take the alias from that. And there are ints with a list of objects. For example, hashjoin has a list of aliases there. This list is not ordered, which means that if you see hashjoin ABC or hashjoin CAB, it means exactly the same. So it doesn't give the information to the query planner that you want to join A to B or B to A. This is just a list saying that when you are joining those three tables, you want a hash join. And anyway, in the PG plan code, they all put that alphabetically. So that's important to know. It may sound counterintuitive if you say hashjoin A or nested loop A, B, it can be A to B or B to A. We will see how to order that. In the leading int, so hashjoin ints about the join method, leading ints about the order of the joins. Which table you want to start, and that's the outer table for the next join. You know that Postgres joins tables only 2 by 2. If you join 3 tables, it starts to join 2 and then another one, which means that there is an order. And the order matters because if you start to join tables with millions of rows and then at the end have a very selective join, then you did a lot of effort to finally discard many rows. So in the leading int, where you mention in which order you want the joins to be, it's the same. If you put it like that, it will not be ordered. If you want to be ordered, so explicitly say, I want to join A to B, and then the result of that to C, you use parentheses. So you have pairs of parentheses that can be nested. So those two are different. Here, I join A to B, and the result is joined to C. Here, I join A to the result of the join of B to C. So actually, it starts by joining B to C as the inner table, the right side of the join, and then joined with A. We will see some example and execution plans to get it. The most important is that if you think you int the right order without all those parentheses, you miss something. Maybe you have the right execution plan now, but the query planner has still the choice to take something else one day. Okay, and yeah, the indexes, so the ints that reference tables, reference them by aliases. Some ints reference the index that you want to use, and with the index name. And a DBA may decide to rename an index, which should be transparent for the SQL, because SQL has this physical logical independence. But if you int with the name of an index, the int will not be used if the index has not this name. So this is an example where I int an index scan when I access to the alias account, and I name an index. And you can see that the plan does a sequential scan, so not using an index. You have a clue that the int was not fulfilled with the cost, because actually when you int something, it doesn't really prevent the query planner to use, it doesn't really force the query planner to use an index scan. It just put an artificial, very high cost to it so that it should not choose it, except if there is no choice. So here, I wanted to force this index, but it was not used. But on the same table with the same indexes, if I put only index scan and only the table name, then I say to the query planner, use an index to access that, but whatever index you want. Basically, the query planner can do everything possible, and within everything possible, your ints will just reduce what it will consider. But you can see that finally, I can do an index scan with this index. So this one didn't find the right index, and then totally ignore the index scan int. Didn't even try another index. And without int, so I've just removed everything in the ints, there you can see that it can do an index only scan on this index, which is much better. So sometimes it can be better without int because the query planner has many choices, and you think that you help in something, but someone has renamed an index, and then your int is completely ignored, and finally, you force a sequential scan where the query planner was okay. So be careful with that, with the naming. That's also why if you use ints in production, not for all queries, those are small workaround, and document it. And do not leave that for too long, because one day someone will rename an index. If you know that you had a performance issue last week and you have added the int and you are looking at the solution, then probably nobody in your team will rename the index at the same time. So document it. Any questions so far? Yeah? Sorry?
In the index-only scan,
yeah,
it means that it could find all the data within the index itself, right?
Yeah, the index-only scan here means that you don't have to access to the table.
In that case, is the table only having just one column, which is user ID?
So this one is because what I did select
so
there, I select start, so I mean I have all the columns in the index there. And that's much faster because you don't have to go to the one. So yeah, this one is much faster. In this case, the query planner was probably right choosing this one, and I tried to be more clever with ints, but I was not for two reasons, because I got the wrong name, and because if I force an index scan, it will not do an index only scan. So no.
In essence, the star is nothing but user ID in your table structure. Is that accurate?
Sorry?
In essence, when you say star, it's only user ID column in your table structure. Is that accurate?
Yeah. If you want, I will show an example on index-only scan, but this is more about ints. But during the demo, I will show an example, yeah.
Thanks.
I will not go into the detail of the different access paths. That can be 1 more hour in case, but yeah.
I
So
have another.
you see that it can be difficult sometimes to get it right, but at least you can troubleshoot.
I have one question.
Yeah.
So what if I have a view which is joining between two tables A and B, and I'm selecting from that view. Can I use hints to force a join, or like,
So if you use a view, then you need to use the aliases after the rewrite. You know the Postgres first rewrites the query, introducing the views, and then there are aliases in that. And then sometimes there is a conflict between aliases. So there, do an explain, and then you will see the real alias in the explain plan.
So is that alias always stable? The rewrites will always be with the same alias, you say?
Yeah, there are cases where Postgres can add an internal alias that you don't see in the query. So always use the explain plan. I will show in the demo. Always use the alias that you see in the execution plan to be sure that it is the right one.
In some rewrites I've seen they at times not use alias also. Like I've seen select 1 and select 2 kind of.
Yeah.
So in that case, how do you?
Yeah, with nested subqueries, you can see something like select 1, select 2. Yeah. But you see it in the execution plan. You cannot guess it. So yeah, check the execution plan. And if it doesn't work as you want, we were about there. So if there is a syntax error in the int, it will tell you, which is already good. But you have seen that when I used the wrong index name, it didn't tell. So you can have more verbose information by setting PGInPlan debug print to verbose. And that goes to the log. If you want that to go to the client or your session, usually I use int when trying different execution plans, so I don't want to go to the log, so set client message to the log. So that's a way to troubleshoot. And so as I mentioned, int doesn't force anything. People think that if you put an int, you force the query planner. You never force the query planner. You just set a higher cost on the other pass. So an index scan int just set a very high cost to the sequential scan. And this is evaluated during the query planning process. If you look at the PGInPlan code, you will see that disabling the cost just adds 10 million to the cost, so a very high cost, which means that it can still be used, but if another possibility is there, it will use another possibility. So I will show you quickly on a demo. Let me check the time. Yeah, time goes fast. Just to show quickly how it works, I will create 3 tables to join them. My goal is to show you that it may not be so easy to set exactly the right join order. So I explain a query where I join from C to B and to A. And to show you that we use aliases, I've put cherry, banana, and apple for CBA. We can use Unicode. That's not our recommendation, but it's funny. So here, without any int, the query planner chooses to start with cherry and join that to banana, building a hash table from banana to have fast join there. And then the result of it, joining that with nested loops, so for each row coming from that, joining that to apple. And now let's say that I want an opposite way. I want to start with A and then B and then C. So let's try just the leading int, but without the parentheses. I mentioned that it's not sufficient, but let's try to see what it does. So I say, start with apple, then banana, then cherry. And you can see that my int was used. It started with apple, and then to banana, but because I didn't mention a join direction, the query planner decided to switch both of them. So it is still joining apple to banana, but building the hash table from apple. If I want to join from apple to banana, I run the opposite. And then went to cherry. So I already reduced the choices of the query planner, but it still has a lot of choices. Just to mention that this will not help. Adding a hash join apple banana, I have already a hash join between apple and banana. This will not change the join direction, as I mentioned. The only way to change the join direction is adding pairs here. So this explicitly say apple to banana and then to cherry. I leave the hash join there to force it in case it wants something else. And if I run that, I have the join direction I want. I want to read apple for each of them, join to banana, and then join to cherry. So the join direction, the join order and direction is the most important. And then be sure that you int everything there. So I had a hash join there, and I've put a int to be sure that it stays like that. And here there is a nested loop. I want to change that to a hash join, so I'm adding hash join there. So I have the join order and the join methods that I wanted. Here, I force really the join order and the join method. The query planner has no other choice on that. Here is an example where, in addition to that, I want to int the access path, not only the joins, order, and directions, but also the access path. I want an index-only scan to banana. If it can, it will do it. If it cannot, it will not. So you can see that it didn't work. Yeah, because I didn't check in Yugabyte, we have changed some access path to make them cluster aware, and then this one is not used. No, sorry, yeah. I was confused because in Yugabyte we have changed some plan nodes, but here I didn't have the index. So I force an index that doesn't exist, so not possible. If I create an index, and this is where we will see the index-only scan, I include some colons to be sure to find everything there. And there you have an index-only scan on that. If you want to be sure about index or index-only scan, let me show you quickly. If I add to the explain here, if I add verbose, it is more verbose, and it says which column are taken in the output. So if you see an index scan only and want an index scan with the output, you know exactly what you have to put there. Here, because the output is n and x, and I have both in the index, it can be an index-only scan. Okay, we have 10 minutes, so I will go back to the slides. And yeah, I did the demo also to show you that it is easy to test. And one day you may need to add ints in production to solve a problem, because an execution plan is bad and is blocking everything. And probably when you have a problem in production, it is not the right time to install the extension, start to learn about inting, troubleshooting, understanding, reading documentation, all that. So better to look at it before, Maybe you don't remember all the subtleties, but at least you know where they are, and you will find the information later, because when you have a problem in production with 10 managers asking you what happens, you will not start to open the books and look at how it works. So that's why I mentioned that it's easy, a small demo on 3 tables. You don't need to add rows on that. I just do an explain. I didn't analyze the table, so that's very simple, yeah. So again, you will not remember this slide. Maybe you can come to it later, because this is what I do. We have seen that to fully int a query, you need this leading with a lot of parentheses. You need the join methods. So if you join 3 tables, you need 2 join methods. And for each table, you need an access method, sequential scan or index scan. And if you do not have all that, you still leave some decision to the query planner. So if you don't want to leave some decision to the query planner, because if you do that, it's already because the query planner cannot estimate correctly the plan. So if you have n table aliases, in my demo I had 3, you may have 10. You should have n-1 nested pairs of outer, inner in the leading int. For each pair, you should have a method, hash join, nested loop, merge join. And they will have from 2 to n aliases. For the first join, the join method will say AB. For the second one, it will say ABC. Join into C when coming from those tables. And then, for each alias, you will have the access path. So sexscan, index omniscan. There is also an index scan regexp. If you have a special naming in your indexes, you may use that. Which means that if you count the parentheses, you should have, of course, the same number of closing and opening parentheses. But if you count them, if you have n aliases, 6 times n minus 2 opening parentheses and closing parentheses. If you don't have this number, either I was wrong, so tell me, or you have missed some int to fully int your query. Okay, just a few more things that we can do with ints. Those were about forcing something in the execution plan. Join method, join order, access path. You can also do something a bit more subtle. If the query planner chooses the bad execution plan, this is probably because the estimation of the selectivity was not correct. Postgres can estimate quite well the selectivity when you query one table, because you have analyzed your table, you have statistics, you have histograms, you have many things. But when you join, it doesn't know this correlation between some data. You may know it because you know the business, you know your data, the query planner doesn't. And then, rather than forcing a plan, you may prefer to just correct the estimation. So for example, there is a rows int where you say, when you join from A to B, instead of your estimation, which I think is bad, just take it as if there are 42 rows, because I know it. Or better, because your tables may grow, when you join A, B, and C together, you usually overestimate the cardinality, and it is actually 1/3 of it. And then you still estimate with your cardinality estimation, but just multiply by 0.3. And then even if your table grows, this is still good, as long as the distribution is about the same. And when you have a correlation, like country and city, then probably the factor will always be the same. So that's also a way without forcing a plan, just to helping the query planner with some information you know about your data. You can also use hints to set parameters. When you set planner parameters, you can set them for the whole session, set parameter equal something. You can set it for the transaction only, if you have a transaction, begin transaction to commit, and then you can set local. But with this set int, you can set a value only for the query. The advantage is that you know that you set something for the query, but even if you forget to set it back to the previous value, it will be done. Very good if you are using a connection pool. You don't want someone to set a strange parameter for his query and then the others reuse it. And for that, this is an example of a special parameter, join collapse limit. If you set it to 1, it can be an alternative to the leading int. If you set it to 1, the query planner will take the table as they come, rather than trying to reorder. It can be a way to force the order of the join without ints, but it will force the order of the join, not the direction of the join. Just mentioning that if you hear about another way of forcing the order of the join, there is one, but better use int, in my opinion. And I did mention, when you set the parameter, remember, those are ints used at parsing time. So you can set parameters that influence the query planner, but everything that is at execution plan, you cannot set it with that. Okay, and then let me check here. We have just 3 minutes. If you cannot change the code, you have to fix something in production, you have a query, and you cannot change the code. There is a way where you can add int without changing the query. So you will, with the extension PGInPlan, there is a table that is created in plan int, and you can put there the text of the query and the int that you want to be automatically happened in front of the query. And of course, if you are not using prepared statement and you have values in your query, you don't want to int for each value, so the values can be replaced by a placeholder. And again, something that may not be easy to remember, so I tested the different combination to be sure about what I'm mentioning. This placeholder for a value can be a parameter if you use the parameter in your query because you are using prepared statements. If you don't use a parameter, if you have a literal value, a number of a string in your query, then you replace it with a question mark. So question mark is for literals, the parameters are for parameters. And also something to remember, I had the problem many times. I just run my query on PSQL with a semicolon at the end to execute it, but do not put the semicolon when you insert the in here, because it will really be compared. PGInPlan will take your query, replace all literals by a question mark, and then compare it. So if you have a space difference, an additional semicolon, anything, it will not take it. So it's a bit tricky. I consider it as a workaround. I do not expect that all your queries are in PGInPlan to force a plan, but at least you have a way live in production to fix something. Okay, and then the core message of it, you may need it. Now, already mentioned, one day you will need it, you may need it, so better understand, know about it before it is critical in production. And it's a very good way to understand the query planner. And on small queries, just understanding why the query planner starts with this table. Is it a mistake of the query planner, or is it a mistake in my understanding? Then you try forcing it, you try the other one, you look at the statistics with explain and the buffers, and you see who were right or wrong, the query planner misestimate, or you thinking that something is better where it is maybe not. Okay, we are near the end. I suggest if you have questions, I will be at the Yugabyte booth just near, so if you have questions, just come, and we have also stickers. I don't know, there is also a game where you can punch on the screen and all that. Thank you very much.